In this video, I will be showing and explaining an addition reaction. Addition reactions are reactions in which atoms are added to a double or triple carbon-to-carbon bond. In this video, we will be specifically looking at alkenes in addition reactions. So in these reactions, a small molecule is added to the alkene in order to break its double bond. This molecule is usually a hydrogen molecule, a halogen, a hydrogen halide, or a water molecule. So here are the different general formulas for each type of alkene addition reaction. The first one is an alkene plus a hydrogen, which has a product which is an alkane, and we can see that the catalyst is plutonium. And the second one is an alkene plus a halogen, which makes a dihaloalkane, and the catalyst is a carbon tetrachloride. Third one is an alkene plus a hydrogen halide, which makes a haloalkane, but this one has no catalyst. And then our fourth one is an alkene plus water, which makes alcohol, and our catalyst is sulfuric acid at 100 degrees Celsius. So the reaction we're looking at is but-1-ene with 1 mole of hydrogen chloride. So first we must identify each reactant. So our but-1-ene is our alkene, and our 1 mole of hydrogen chloride is a hydrogen halide. And we know this because it contains 1 hydrogen atom and 1 chlorine atom. So knowing our reactants are an alkene and a hydrogen halide, we can predict what catalyst the reaction will need and what product it will create. So we can refer back to the first sheet. Here we can see that an alkene plus a hydrogen halide has no catalyst and it produces a haloalkane. So here I have the general formula of an alkene plus a hydrogen halide in a structural diagram. So we can see the alkene here. We can see the double bond, and we can see the hydrogen with the halogen as a hydrogen halide, and then we can see our product. So this diagram just gives us reference as to how our double bond is going to be broken by our hydrogen chloride and what kind of alkene it's going to create. So before we actually predict the product of our question, we must discuss Markovnikov's rule. Markovnikov's rule states that the hydrogen of the small molecule, which in our question is the hydrogen chloride, the hydrogen will attach to the carbon that is already bonded to the most hydrogens. So in simpler words, the carbon that is the most hydrogen rich will gain the hydrogen from the small molecule. So now that we know what type of reaction we have and we are aware of Markovnikov's rule, we can begin to predict our product. So we have but-1-ene, which we said was an alkene. So we can draw that. So but means that there is 4 carbons, and the 1-ene means that the double bond is on the first carbon. So just to make the process a little easier to visualize, I've put the double bond on this end of the carbon chain rather than that, just so we can see the double bond break more easily. So we can draw the hydrogens now, which are all insignificant, and then our hydrogen chloride, which is just like this. So we know that in addition reactions, our small molecule, hydrogen chloride, breaks the double bond of the alkene. So what's going to happen is this double bond is going to break. So once the double bond breaks, our carbon chain should look like this. And we must also note that these atoms of the small molecule will always bond to the carbons that were a part of the double bond. So it will be carbon 1 and carbon 2. The atoms of the small molecule will never bond to the other ones. That is when Markovnikov's rule comes in. so we have to determine which of the two carbons the molecules will actually bond to. So as it's stated, the hydrogen of the small molecule will always bond to the carbon, which is the most carbon rich. So in this case, carbon number 1 is a terminal carbon, therefore it's bonded to 3 different hydrogens, while carbon number 2 is only bonded to 2. So we know that the hydrogen of hydrogen chloride must bond to carbon number 1. So just once again, the double bond will be broken, and because this terminal carbon will become the most hydrogen rich, our hydrogen from our hydrogen chloride will bond with this carbon, and our chlorine will bond with this carbon. So now we can draw our final product. So our final product is going to be a 4-carbon chain haloalkane, and we said our hydrogen will be on the last carbon, or the first carbon, sorry, and the chlorine will be on the second. So we can add the significant hydrogens now. And now we can actually name the haloalkane. So we said this is carbon number 1. This is carbon number 2, 3, and 4. So we have to look at the branches. We have a branch on the second carbon, so it would be a 2-chlorobutane. So this is our product when we follow Markovnikov's rule. So in other words, this is our major product. However, if you do not follow Markovnikov's rule, there is another possible product, which is what we refer to as the minor product. So if we were not to follow Markovnikov's rule, our hydrogen could bond to the second one rather than the first one. So we would end with this as our final product. The chlorine would be attached to carbon number 1, and the hydrogen will be bond to carbon number 2. So here we can see the difference between our major and our minor product. So thank you, Miss Mo, for watching, and I hope you liked it.